All right, guys. So in this video, I'm going to go through how to solve radical equations, but in the form of rational exponents. Remember, a rational exponent is just a radical equation. It's another way of writing it. So just as a refresher of our memory, if I have something a to the m over n, that is the same as taking the nth root of a to the m power, or you can even see it written as the nth root of a all to the mth power. Okay, so that's why we do rational exponents in with our radical equations lesson, because they're identical. They're the same thing. It's just a different way of looking at the problem with a slightly different way of solving it, but the same ideas. So meaning when we were solving radical equations, we had to get our radical by itself. So in this case, we want to get our rational expression by itself. So the first thing we want to do is add or subtract, multiply, divide, get rid of anything that is not a part of that exponent. So in this case, we're simply going to add the 2. Okay, once we get to here, now to get rid of that radical or a rational expression in this case, you're simply going to raise it to the reciprocal power. So 3/4, its reciprocal is 4/3. And what I do to one side, I got to do to the other. All right, that will always end up canceling out, because when you do your multiplication or your distribution of your exponents, 4/3 times 3/4 is going to be 1. So those are going to go away. And then just what's left inside, 3x will drop out. 27 to the 4/3, just put it in a calculator. It'll come out for you. It comes out to 81. If you really wanted to, you could do the third root of 27, raise it to the 4th power, which would be 3 to the 4th power, or 81. However you want to go through doing it. But calculator, best friend, you can use that. From here, you simply just finish the problem, divide it by 3, get x by itself, and you get 27. You still want to get in the habit of checking, because we could have extraneous solutions, just like we did with radicals. So again, once you have your final answer, just plug it back in. When you're checking, what is really important is you plug it into any original problem, and you simply just simplify one side at a time. So make sure you go through, obviously I have nothing to do on the right side, but in this one, we would do 3 times 27 first, get 81 to the 3/4 power. You would then raise that to 3/4. You get 27. 27 minus 2 is 25. So that did work out. So this is my answer. Okay, it was not an extraneous solution here. Okay, same thing's going to happen with the second problem, right? I have the parentheses already are by itself, so I don't have to move anything. I'm going to raise it. 3/4 we know is 4/3 again. I guess I like that fraction. Okay, I'm going to put that in my calculator. 8 to the 4/3 comes out to 16. So I have x plus 2 equals 16. Again, if you wanted to go through the long way, you could. The third root of 8 is 2 to the 4th power is 16. And at this point, everyone should know how to solve this one-step problem. Subtract the 2. So x is 14. Again, we're just going to double check. By the way, checking not only does it help you figure out if you have extraneous solutions, helps to make sure you did the problem right. Because if it works, you know you did something right. Okay, again, nothing to do on this side. 14 plus 2 is 16. 16 to the 3/4 power does work out to be 8. So it worked. I know that's my solution. Okay, last one, same thing. I have a rational exponent. It's already by itself, so I can raise it to the reciprocal. So this time 1/2 is 2 over 1, or just 2, which is fine. X plus 12 drops. And then this becomes x squared. Remember, anytime we have a quadratic, your best bet is to get one side to be 0. You will often want to keep your squared one as a positive, so move everything else to the other direction. And then you solve. Quadratic formula, factoring, square root method, whatever looks easiest. This is factoring. Factors of -12 that add to it -1 are a -4 and a +3. So we have x equals 4, x equals -3, and we're going to check both of those. Okay, so the first check I'm going to do with x equals 4. So 4 plus 12 to the 1/2 has to equal 4. That's going to be the first thing I check. 4 plus 12 is 16. 16 to the 1/2 is 4. So that works because the right side was just 4. Definitely one of my solutions. Second one, now we're going to put a -3 in. -3 plus 12 to the 1/2 power equals -3. -3 plus 12 is 9. 9 to the 1/2 is 3. But the right side was -3 the whole time. So this one does not work. So -3 is my extraneous solution. Answer to the problem, but not the original problem. So x equals 4 would be the only one in this case. Right? Hopefully that helped you out with understanding those a little bit better.